Last Monday, right? We had the PO paper. Today, they are supposed to have their applied paper, but it was postponed. And in the PO paper, the problems they had were very similar to our problems in the tutorial and the papers. For example, the problem I gave 25 batch last week, the problem on differentiation, the same question was there in the paper. So all the questions are like that, except one part. Everything was very similar to the questions contained in the papers. I mean, in the papers means the papers I gave to the students, right? Okay, but your class is much better than that. So therefore, you will do really well. I think most of them, like out of 5 questions, I think everybody did more than 3.5. So that's pretty good. Because mathematics, I mean, combined math is something in which in which nearly 55% get through. It means that 45% don't get through. But this means everybody has either a lowest grade would be a C, most probably B. Usually in combined with this, how you get, they get 5% of A's, like 12% of B's, usually, yeah, average. C is like probably 18%. If you need a 44, something like that. Not exactly. Some should be 100. So 17, 35, 59. No, it should be something less. 15, 33, something like that. So it's really hard to drive everybody to have either A or B. But this time, I think nearly 70, I mean, more than 80% will get A's or B's. Right? I mean, in our class. Okay. So we can come up with the new section. We can start new section. Oh, before that, we have to go through some problems. I think we didn't do this. Our original plan was to do the class till 6 o'clock, but due to the prevailing weather, we can, prevailing bad weather, we can wind up a little early. However, the epicenter is moving, but still, the rain will be subdued very soon. But still, earth slips will be there. Therefore, we better get going a little early. Like we can wind up by 4:45. Okay. So we did this. Did you do this problem? No, probably not. Right? We did. No. This is the tutorial, but okay. We do some difficult problems today. Hmm. Second, I'll do those two later. B. Did you do this? No. Yeah, before getting into the new section, we'll go through this first. Right? And there's very interesting problem. We'll do those. However, these are little difficult ones. Okay. No, okay. These are. Mostly they are from double and triple angle formulas. Hmm. Okay. I'll recall the formulas we need to do these problems. Sine 2 theta. There's only one formula for this. For cosine 2 theta, you have three formulas. One is cosine squared minus sine squared. Second is 2 cosine squared theta minus 1. Third is 1 minus 2 sine squared theta. Then you have two formulas for cosine, I write sine 3 theta. Sine 3 theta starts with, like, both cases you have something like this. 3x minus 4x cube. In one formula, you have the negative of that. But sine 3 theta contains only sine theta. Similarly, cosine 3 theta contains only cos theta. So this is like 3 sine theta minus this. Here, you multiply it by minus sign and replace sine by cosine. So you get 4 cosine cube theta minus 3 cos theta. Mm, I think that would be it. There's one more. From 2 theta. Cosine squared theta and sine squared theta can be expressed only in terms of cos 2 theta. This is 1 plus cos 2 theta over 2. This is 1 minus cos 2 theta over 2. They look alike, but the only difference is that here you get a plus sign, here you get a minus sign, because those are derived from these two. Hmm, right? So here, since it is a formula formula for cosine 2 theta, cosine 2 theta, cosine squared gets the preference. Here you get a positive sign, but in the case of sine squared, you get a negative sign. Now we'll do those problems. Sine A plus B, cosine A plus B, you know those. You're supposed to know those formulas from top of your head. Now we'll start with this. Cosine 20 need to show. You can start from the left-hand side. Hmm. You can see that except this cosine 60, right? The other angles are in the geometric series 20, 40, 80. When you multiply 20 by 2, you get 40. When you multiply 40 by 2, you get 80. This is half. So I'll pull that out. Half. Cos 60 is half. Then cosine 20, cosine 60. It looks like an arithmetic series. Because you add all the time, you add 20. 20, 40, 60, 80. But if you remove this, since you know the exact value of this, if you remove that, it looks like a geometric series. 20 times 2, 40. 40 times 2, 80. This 40. Now, how do you deal with this? Now, you may tend to use something for cosine 2 theta. But cosine 2 theta don't have a product. I mean, cosine 2, the formula for cosine 2 theta doesn't have a product. It has a sum or difference. This is where you have a product. Because now you have a product, right? Something multiplied by another, multiplied by the third term. Therefore, if you try to insert something for like cosine 20 or cosine 40, it's hard to simplify. Therefore, you have to come up with the product. Then you can expect some cancellation. So this is where you have a product. That's the only formula that you have a product. Now you can write cosine theta, but this format is rarely used. Sine 2 theta over 2 sine theta. If you try to write it like that, look, 2 theta appears at the top, theta appears at the bottom. Since it's a geometric series with the common ratio 2, you can expect some cancellation. So that's the only hope, and that's the only method that you can do it. There's another method, but that method will take a long time. Like you have to, if you use that, if you adhere to that method, it takes a longer time. Therefore, if you use the method that I am proposing, probably in 3 lines you can get the answer. Right? This is what we are using. Cos theta, because we usually don't use this format, 2 sine theta. For this cosine 20, you can use this. Right? Sine 2 theta means the angle should be doubled. Here you can leave the same angle. So sine 40, angle is doubled, divided by 2 sine 20, same angle. Here, sine 80, it's doubled, 2 sine 40. Here's double the angle, sine 160 over 2 sine 80. Now you need to prove that it is equal to 1 over 16. 2 times 2 times 2 times 2 will give you 16. That means you have to cancel all the other terms. Sine 40 will go away with this. Sine 80 will go away with this. It leaves you with sine 160 at the top, sine 20 at the bottom. So you have, there are 4 2s. 2 to the power 4 is 16. Here you have sine 160. Here you have sine 20. But what is sine 160? If you have 160, it is somewhere here, 90 plus 70. So this should be 20. So you can write 160 as 180 minus 20. So what is this? Sine 180 minus theta is sine theta. So this should be sine 20. So these two go away, leaving 16 as your answer, which is the RHS or right hand side. Right? Here, in the second one, this is what you need to do. I'll do part B for you. You do part C. Then This part is little different. This we'll do these two later. I'll do part B. Now the weather is getting better, right? Uh, I didn't want to cancel, in fact, but a lot of parents called number 0 and they asked, okay, whether you have the class or not. Then finally we cancelled, I mean, we cancelled the physical version of it. So we'll go for part B. So we have this. This is what you need to show. You can start from the left-hand side. There are two methods I mean, that can be applied to do this problem. I'll use the method that we learned in section 3.1. But there's one little topic left, which is called product formulas. Right? If you have that, you can apply that formula for this product to get the answer a little quicker. But here you can do this. This method is not bad. The method that I'm going to use here. But I'll do these two problems, I mean, B and C again when we do section 3.5. Now you expand this. This is like sine A plus B. So sine A cos B plus cos A sine B. Then you have another thing called sine 60 minus alpha. It is sine A cos B minus cos A sine B. Okay, sine 60 cos alpha plus cosine 60 sine alpha. Here you get sine 60 cos alpha minus cosine 60 sine alpha. Now you can see that this is like, if it is A, if this is B, this is like A plus B, this is A minus B. You can identify it as factors of a difference between two squares. So if you multiply them, you get A squared minus B squared. Right? It is something like this. Say you have A minus B times A plus B. You can write it as A squared minus B squared. But if you have in this format, say PQ minus RS, PQ plus RS, still you get PQ quantity squared minus RS quantity squared. So it is like PQ quantity squared minus RS quantity squared. Means what? This is P squared Q squared minus R squared is squared. So when you multiply this, what would you get? Square of this minus square of this. When you take the square, you have to square each and every term in the product. It doesn't mean that A squared, I squared, N squared like that, but sine squared 60 times cosine squared alpha. Right? Okay. This is cosine squared 60 sine squared alpha. Now we need to show that it is equal to sine 3 alpha. Look, this is sine 3 theta. So if it is sine 3 theta, you have to write everything in terms of sine theta. In part C, if you want to show that it is equal to cosine 3 theta, everything should be in terms of cos theta. Now, here you have to write everything in terms of sine theta. At the same time, you have to plug in the values for these. What is sine 60? Is square root 3 over 2. Right? Sine 60 is square root 3 over 2. I mean, in the answer, you don't have to write this, but for your reference, I'll write it like this. Sine 60 is square root 3 over 2. Cosine 60 is half. Right? Now, what is this? This is the square of sine 60. Hmm? We'll insert one more term, it's okay. This is cosine squared alpha. We like to have everything in terms of sine. So I'll write it like this. This is half square, square of the half. This is sine squared alpha. Now you can simplify that. This is 3 over 4. This is 1/4. This minus, sorry, sine squared alpha. Now you can simplify this. You can pull out 4 from the bottom, like from the downstairs. When you pull out 4, you get 1/4. Right? The 1/4 you need. You got it. Now you have sine alpha. In the bracket, don't write this 4 again. 3 times 1 minus sine squared alpha minus sine squared alpha. So what do you get? This is 3. Then you get 3 sine squared alpha minus sine squared alpha. So altogether you get 4 sine squared alpha. Because minus 3 minus 1. Now what is this? You can multiply everything by sine alpha. You get 3 sine alpha minus 4 sine cube alpha. What is this? This is the formula for sine 3 alpha. Right? So it is 1/4 sine 3 alpha. That's what you need, which is the right hand side. Right? When it comes to cosine, you write the same formula. You write it like this. I mean, similar formula. Cos 60, cos alpha. But here you get minus sine because cos A plus B is cos A cos B minus sine A sine B. So cos 60 cos alpha minus sine 60 sine alpha. Here cos 60 cos alpha plus sine 60 sine alpha. Then since you are looking for this answer, replace every sine by cosine. When you have sine squared, you write it as 1 minus cosine squared. Eventually, you will get this. The lines are very similar. Do up to part 3 and try part 4. I'll do that for you, right? I'll do part 4 for you. First, take this down and then do part C and try part D. Hmm, okay. Again, you can start from the left-hand side. Then you can expand these two using cos A plus B and cos A minus B. Cos 60 cos alpha minus sin 60 sin alpha. Similarly, cos 60 minus alpha is cos 60 cos alpha plus sin 60 sin alpha. Again, it is like A minus B times A plus B. So you can write it as a difference between two squares. But here you get cos squared 60 cosine squared alpha minus sin squared 60 sin squared alpha. Now plug in the values for these two and replace this one by 1 minus cosine squared alpha. If you're done with the third, do fourth. Do the fourth. It is a little different. Right. I have to complete this. I have to complete the third one. Now, cosine 60 is half. This is square root 3 over 4, quantity squared. Right. So the lines are very similar to this one. Now you can square this. Right. This is 1/4. This is, I'm sorry, this should be 2. So this 3 over 4. And we are planning to obtain a formula for cosine 3 alpha. Therefore, this should be replaced by 1 minus cosine squared alpha. Because we need everything in terms of cosine. Now, you can pull out this 4 from the bottom because we need 1/4 in the final answer. You have cosine alpha. So what leaves inside the bracket is cosine squared alpha minus 3 times 1 minus cosine squared alpha. Now you can simplify the bracket. This is cosine squared alpha. These two negative signs will make it positive. Uh, it gives you 3 cosine squared alpha. So if you add these two, you get 4 cosine squared alpha minus 3. Now multiply what you have in the bracket by cos alpha. 4 cosine cube alpha minus 3 cos alpha. Most of you have, forgotten this bracket. Then it's wrong. Because if you write it like this, only this is multiplied by 1/4. Therefore, you need a bracket like this. Then this is cosine 3 alpha, which is the right-hand side. Right? Now we'll do the fourth. Here there's a little, it's not a little mistake. Huh? It's a huge mistake. This should be positive. Otherwise, you cannot get this done. Now we'll do parts D and E. Part D. Okay, we can start from the left-hand side. So this is what we have. Now we need to show that this is equal to tan 8a over tan 2a. So at some point you need to have this. Tan 8a is sine 8a 8a over cosine 8a. Below that you have tan 2a. That means sine 2a should be at the bottom. Cosine 2a should be at the top. Right? That's what you need to obtain. So all the terms containing 4a should be eliminated. So you need to have something like this. This gives you tan a. This gives you 1 over tan 2a. This is tan 8a. This is 1 over tan 2a. So if you get cosine 8a in the downstairs, leave it as it is. If for some reason, if you get sine 8a in the upstairs, leave it as it is. Right. Now uh, we don't know what to do with this. Therefore, at least we have to convert this into cosine. This 1 over cosine 8a. Now you can take the common denominators, or you can you can multiply both upstairs and downstairs by cosine 8a times cos 4a. Bro, that's not going to work. So we'll do it like this. This is a big division, this division. So you take cosine 8a as the common denominator for the upstairs. You have 1 minus cosine 8a. In the downstairs, you have cos 4a. You have 1 minus cosine 4a. Right? Now, you can multiply it like this. 1 minus cosine 8a divided by cosine 8a. So this should you can solve these two and multiply. So cosine 4a will appear in the upstairs and this will appear in the downstairs. Look, you got what you want. At least you get this cosine 8a in the downstairs. You have that. You need to convert these two into some kind of single term or product, because you don't have any sum or like sum or difference. This is a product, so you have to make it a product. 1 minus cosine 2a, 1 minus cosine 2a like thing. So we'll see what it is. We can go over there. Look, 1 minus cosine 2a over 2 is sine squared theta. That means 1 minus cosine 2 theta is 2 sine squared theta. Right? 2 sine squared theta. So what you need to do is that you have to divide this angle by 2. Right? Then 2 sine squared that. Now, you have to divide this angle by 2. So it will give you 2 sine squared 4a. You have to divide this angle by 2. Right? Uh, and here you have cos 4a. You do the same thing. 2 sine squared, you divide this angle by 2. Look, you need sine 2a and cos 8a in the downstairs. Right? You have cosine 8a here. And you can cancel these two. You have one of them. You need cosine, sine 2a there. So that's okay. But one sine 2a should go away. And you need to come up with sine 8a, this one. Right? How do you get sine 8a? Sine 8a is 2 sine 4a cosine 4a. That is sine 8a. Right? Because sine 2 theta is 2 sine theta cos theta. Here, if you have an angle like this, when you divide that angle by 2, like sine 2 theta is 2 sine theta cos theta. Whatever the angle you have to divide it by 2. Like sine 100 theta is 2 sine 50 theta cosine 50 theta, like that. So you can break this into this one. At the same time, when you have this combination, you can write it as sine 8a. Right? Okay. Now we'll try to gather those things. You have, okay, 2 sine 4a cosine 4a. You can write them together. But you have extra sine 4a. Right? We don't need 4a anyway, right? So you write 2. It's better to have this 2. Because you need 2 there anyway to find the double angle. I leave this here. Now 2 sine 4a cosine 4a will give you sine 8a. That is what you need. Hmm? But you have extra sine 4a. You have sine squared 4a there. You have an extra sine 4a divided by, you have cosine 8a. That is something you need. But then you have 2 sine 2a. You need sine 2a. So I'll write just 1 sine 2a here. The other can be written as 2 sine 2a. I mean, I broke this into 2. Sine 2a, like it is like 2x squared. X times 2x. So sine 2a times 2 sine 2a. You need these two there. You have them right there. And you have sine 8a up there. If you write it as one term, it is sine 8a. You have cosine 8a. So that will give you tan 8a. Here you have sine 2a. You need to have cosine 2a in the upstairs. Right? This is something extra. You don't need that. You have to cancel it with something. Here you have sine 4a. Again, you can apply that formula, double angle formula. Sine 4a means 2 times what? Sine 2a cosine 2a. Right? Now this will go away with this, leaving exactly what you need at the top. Sine 8a cosine 2a, cosine 8a sine 2a. This will give you tan 8a. But it's cos over sine, means cot 2a. So cot 2a is 1 over tan 2a. Right? In the next problem, part E, I'll give you a start. It is sixth power. Clearly, you can start from the left-hand side. You can write this as sum of two cubes. You see, if you write it like this, 2 times 3 is 6. 2 times 3 is 6. If you have something like this, how do you factor? Like, how do you factor something like this? You first close these powers. What you can see is x plus y. Then the next factor can be obtained by squaring this, square the last term, write the product in between. Don't write 2xy, just xy. Then here the signs are, signs remain unchanged. Always it's positive. Here you have to alternate the sign. So you do the same thing for this one. Here in this case, x is, when you close these cubes, this is x and this stands for y. So in the first factor, you get cosine squared theta plus sine squared theta. In the next factor, you get the square of this, which is cosine 4 to the power theta. This is sine 4 to the power theta. In the middle, you have the product of these two. this plus, this minus, plus, minus, plus. After that, you can probably write these two. Like for cosine squared, you can use this one. For sine squared, you can use that and expand. There are some other methods also. You can do that. You try to continue from there. I'll help you, but you try to continue from there. Right. Right. Here, cosine squared plus sine squared is 1. So when you multiply something by 1, it doesn't make any difference. Therefore, you will end up with this, I mean, what we have in the bracket as the next step. Or if you want, you can write it as cosine squared plus sine squared minus something. That's also another possibility. Hmm. Or if you want to have symmetry, you can write 1 plus cosine 2 theta over 2 for this one, 1 minus cosine 2 theta over 2 for cosine squared and sine squared. This is 1 times. This way you can preserve the symmetry. This was the shortest way of doing it. This is the square of cosine squared. Cosine squared is 1 plus cos 2 theta over 2. This is 1. I think I have forgotten something. There should be an 8 in the downstairs. 8. 5 plus 3 cos 4a over 8. Now, this is 1 plus cosine 2 theta over 2. This is 1 minus cosine 2 theta over 2. This is 1 minus cosine 2 theta over 2 and get the quantity squared. Because this is cosine 4 means cosine, the square of the cosine squared. That's why you have a square. This is cosine squared, square it. You get this. This is cosine squared, this is sine squared. This is this is the square of the sine squared. Hmm. Right? Because we have this. I'm using these two. Sine to the power 4 means square of sine squared. Cosine 4 means square of the cosine squared. Right? Now you can simplify inside. It's kind of straightforward, even though it's not the shortest method. Hmm. Now, you square it. It is like a plus b, quantity squared. You have 1 plus 2 cosine 2 theta plus the square of this, which is cosine squared 2 theta over 4. Because 2 squared is 4. When you have a division, you have to square both upstairs and downstairs. This is the difference between two squares, right? 1 plus, a plus b, a minus b. So 1 squared is 1. You get cosine squared 2 theta. Downstairs you get 4 because 2 times 2 is 4. Here. Downstairs is 4. Here you have a minus b, quantity squared. So you get a squared minus 2ab plus b squared. Now 4 is common 4 is the common denominator. One plus one minus one. Right? You get 1. 2 cosine 2 theta. This is minus 2 cosine 2 theta. Those two will go away. So you don't need the long line here. Right? There are 3 type of terms. Constants. 1 plus 1. 2 minus 1. So it is 1. 2 cosine 2 theta minus 2 cosine 2 theta. That is 0. Then square terms. Cosine square 2 theta, cosine square 2 theta. So 2 of them. Here, this is minus times minus means plus. Right? So cosine square 2 theta, cosine square 2 theta. There's another cosine square 2 theta. This is also positive. So you get 3 cosine squared 2 theta. We are almost done now. Again, you apply the same formula because you need 4 theta, right? Now look, if you have cosine squared theta, you can write it like this. If you have, say, cosine squared 5 theta, this should be 10 theta. You have to double the angle. Hmm? When you have cosine squared 2 theta, this should be doubled. So this should be 4 theta. If this is 50 theta, this should be 100, like that. So it should be 1 plus cosine 4 theta over 2. This guy, right? Now this 2 should be eliminated. To eliminate that, what should you do? You have to multiply both upstairs and downstairs by 2. There are 3 terms. 1, 2, 3. Multiply everything by 2. This should be 8. When you multiply this by 2, you get 2. When you multiply this guy by 2, this will go away. When you multiply this by 2, these 2 will go away, leaving 3 times 1 plus cosine 2 theta. Now eliminate the brackets. 2 plus 3, 5. 3 times this. This should be wrong. Here the angle should be doubled. Angle should be doubled, sorry. 3 cos 4 theta. Right? So this is the right hand side. Now we'll do two more problems. We'll do 31 and 32. Sorry. Yeah, 31, not 31. Yes, 31 and 32. 31 and 32. Okay, I'll do that for you. Huh? 10, sorry, problem 31. In 31 and 32, first you have to prove a result. Then using that result, you have to deduce something else. Hmm. So this is what we need to show. So here you have to convert everything to theta. So the left-hand side, you can start from the left-hand side and convert all the angles to half angles. So for the time being, we have no clue. Usually it's better to, because we don't have formulas for cot 2 theta and cosec 2 theta, write everything in sine and cosine. This cos 2 theta over sine 2 theta. This is 1 over sine 2 theta. Now you can take sine 2 theta as the common denominator. You have cosine 2 theta plus 1. What is cosine 2 theta plus 1? That formula is over there. 1 plus cosine 2 theta is 2 cosine square theta. Oh, you can use one of these formulas. That's also possible. For cosine 2 theta, you write something that cancels 1. That's also possible. No? So you have this. Now we are going to convert everything to theta. Here you need to substitute something which has minus 1. So you use this. So these two will go away. Because you need a product, right? Before obtaining cot theta, you have to come up with cosine over sine. So all summations should be cancelled out. At the same time, you write the only formula you have for sine 2 theta. These two will go away. That leaves you 2 cos square theta over 2 sine theta cos theta. These two will go away. One cosine will go away with this. That leaves you with cosine over sine, which is cot theta. Hmm. Right. Now you have to deduce this result. 1 over sine 2 alpha. Now we have no clue what to do. Therefore, you write sine in terms of, like cosec, because we have something for cosec. You can write this as cosec 2 alpha. This is cosec 4 alpha. Third is cosec 8 alpha. And you can see that the angles are doubled every time. The angle is doubled, right? So this has something to do with that. Look, you can now, this is the double angle. Cosec 2 theta can be written as cot theta minus cot 2 theta, right? Cosec, this is the only place you have cosec. You can write cosec 2 theta. Deduce means you have to obtain that results using this. Deduce means this, right? You obtain something by deducing. It means that you have to use the result you obtained just now to show this result. So cosec, this is the only place you have cosec. Cosec is cot theta minus cot 2 theta. Now we'll use that using cosec 2 theta is equal to cot theta minus cot 2 theta. You don't have to write this in the answer, but just to see what's going on, just to have everything clarified, I have inserted this step. Now for this one, you can write cosec 2 theta. Exactly alpha is in the place of theta. So you can write this as cot alpha minus cot 2 alpha. Plus. Next one. When you have cosec 4 alpha, how do you obtain 4 alpha from this one? You have to substitute 2 alpha for theta. Because 2 times 2 alpha is 4 alpha. So 2 alpha. That means cot 2 alpha minus cot 4 alpha. Then go for this one. 8 alpha. How do you obtain 8 alpha? Then substitute 4 alpha for this one. So cosec 4 alpha minus, sorry, other way around. 4 alpha here. Cot 4 alpha minus cot 2 times 4 alpha means 8 alpha. Finally, this guy, 16 alpha. You can substitute 8 alpha for this. So this is 8 alpha. Cot 8 alpha minus cot 16 alpha. Now, what happens when you add? This is minus cot alpha, this is plus cot, sorry, minus cot 2 alpha, this is plus cot 2 alpha. These two will go away. Cot 4 alpha minus this plus cot 4 alpha. Minus cot 8 alpha plus cot 8 alpha. Now, it leaves you with cot alpha minus cot 16 alpha. I think that's what we need to show. Right? Okay. Now, we have to come up with another result. If alpha is 2 pi by 15, we have to show that this is equal to 0. Now you can again write this. Sorry, this should be 2 alpha. We don't have to substitute values for this side, but we'll substitute the value for the right-hand side. Now alpha is 2 pi by 15. Now it is equal to this, right? Now substitute 2 alpha by 15 for this. Sorry, 2 pi by 15. Put 2 pi by 15. minus cot 16 alpha. Now we have no clue again. We'll now go for this. Cot 2 pi over 15 minus cot. This is 32 pi over 15. Right? You can divide 32 by 15. Answer is 2. Forget about 5, this one. Forget about this. When you divide 32 by 15, you get 2. What's the remainder? Remainder is 2. Right. So you can write it like this. Cot, you can write this as 2 plus 2 over 15. Is that correct? Yes, because look, if you take 15 as the common denominator, the answer is 30 plus 2, 32. When you divide 32 by 15, the answer is 2. The remainder is 2. So 2 over 15. Now you can write it like this. Cot 25 over 15 minus cot. When you eliminate this bracket, you get 2 pi plus 2 pi over 15. We know that no matter what the trig function is, if you go exactly one circle, one rotation, like say this theta, when it is 2 pi by theta, still you get the same values because we are in the same quadrant, same place. Therefore, 2 pi by theta, sorry, 2 pi plus theta is the same. Therefore, this is 0. Right? Okay. You take that down and try to do 32. In 32, the cancellation occurs in a different way. Here, the cancellation occurs like this, minus, plus, minus, plus. Hmm. But in 32, again, there's a cancellation, but it happens in a different way. You try it first. Again, you have to prove something and then show that a certain product is equal to cosine 27 alpha times sec alpha. Okay. Today, rather than going through the problems restlessly, I gave you some time to process the problems. So I'll do 32 now. Most of you today we have physically. I mean, you have done pretty good job. Most of you have got 32. That's good enough for the time being, huh? Because this is your first year of A levels. If half of you crack this problem, that would be good enough. Hmm. Right, 32. We need to show this one. Cos 3 theta is equal to cos theta times. Right. Now, to prove this, okay, let's see how we can do it logically. This is the formula for cosine 3 theta. It's given in terms of cos theta. But in that particular problem, in the left-hand side, you have cosine 2 theta. Cosine 2 theta has three formulas. Since we need to find everything in terms of cosine theta, you have to stick to this one. I mean, using the first one or the third one, still you can do it, but it's longer. So use the second formula you have. Then you can write everything in terms of cos theta. So starting with right hand side, here we have to start off with the right hand side. Cos theta times 2 cos 2 theta minus 1. 2. Now for cosine 2 theta, you write 2 cos square theta minus 1. Now eliminate the bracket sitting inside this, I mean, eliminate this one. So you have 2 times 2, 4. 4 cosine square theta. Minus 2 minus 1 is minus 3. Now eliminate the larger one, this bracket. 4 cosine cube theta minus 3 cos theta, which is cosine 3 theta, which is the right hand side. Now, you need to show that 30, okay. 2 cosine 2 alpha minus 1 is equal to something like this, right? Yeah. Now we can start from the left hand side and you can use this formula, what we have just reduced. I mean, just proven. Like you can see that you in that product in the left hand side, you all the time you have something like this 2 cos 2 theta minus 1, right? So you can make this the subject. So using 2 cos 2 theta minus 1, which is equal to cos, okay, equal to cos 3 theta divided by cos theta, right? Now what is this? If you compare it with this one, alpha is theta. Therefore you can replace it by cos 3 alpha over cos alpha. Now here, if you compare it with this one, how do you get 6 alpha? You have to substitute 3 alpha for theta. මෙන්න මේ ලයින් එක ඔයගොල්ලෝ හරියට ලියලා නැහැ. ඒකයි හිරුනේ සමහර අය. මේක ලියන්න ඕනේ. ලියලා මේක alpha වලින් එහෙම ලියන්න එපා. මේක theta වලින් ලියන්න ඕනේ. Theta වලින් තියෙන්නේ. Then you can find the suitable value that should be substituted for theta. I mean, you need 6 alpha. Here you have 2 theta. So for theta, you have to choose the appropriate value to be substituted. So it should be 3 alpha here. To get 18 alpha from 2 theta, it should be 9 alpha. මේකත් alpha වලින් දාත්තම වර්ග පේන්නේ නැහැ. එහෙම ලියන්න එපා. හරි. මේ පොඩි ස්ටෙප් එක නැති හින්දා බැරි වුණේ. නැත්තම් මෙතනින් ඔක්කොටම ඔක් කරන්න පුළුවන්. හොඳට කරන්න පුළුවන්. ගොඩක් අය කරා ඇත්තටම. يعني these are like, I think these two are past paper problems before 2000, right? Before 2000, the objective is to fail the students. The main objective is that. ඒකයි fail කරන්න බන්නේ before 2000. පස්සේ 1888-89 insurrections වලට අපි මේ මොනවාද government appoint කරා committee එකක්. That's the committee which proposed to reduce the A-level subjects to 3 and make easy papers and give opportunities for A-level candidates, or not candidates, who get through A-level exam. Some universities, like they improved the Open University. They provided more chances in Open University. And they funded SLIT, institutes like that, so that those who get through A-levels get more opportunities afterwards. ඒක තමයි ඒගොල්ලෝ කරේ. ඒතර මේක තිබුණේ ඊට කලින් both problems. මේකත් එහෙමයි. But I think I'm happy with what you have done, because this is your first year. Probably still we are in our first 6 months. We have nearly 2 more years for our A-levels. ඒතර 2 years වලට ඔයගොල්ලන්ට ගොඩක් හොඳට කරන්න පුළුවන්. මේ level එකේදී මට හිතෙනවා ඔයගොල්ලෝ කරපු විදිහ ගොඩක් හොඳයි. නමුත් මේක පොඩ්ඩක් insert කරන්න මීට වඩා ලේසියෙන් කරන්න තිබුණා. Okay, now you go for this one. If you compare these two, you can substitute 3 alpha for theta. Then you get 6 alpha, right? 2 times 3 alpha, 6 alpha. So since theta should be 3 alpha, you have to substitute 3 alpha for this theta. So 3 times 3 alpha is 9 alpha. This is just cos theta, so it should be 3 alpha. In the next term, next bracket, this is what you have is 18 alpha. Otherwise, this is exactly the same as this. The only difference is this theta. For 2 theta, you have 18 alpha. Means theta should be 9 alpha. So this is 9 alpha. So 3 times 9 alpha, 27 alpha. This is 9 alpha. Now you can write cos alpha as 1 over cos alpha is sec alpha. That's it. Now, like ability, I would say mathematics is simply the ability to identify the patterns. Most of you have identified these patterns, but some of you have written 7 for this, 19 for this. I don't know where they are coming from. 7, 19, 13, numbers like that. It should be the multiples of 3. But if you figure that out, this shape, that's very important. I think most of you have come up with this one, at least more than 50% of you. That's good. Okay, now we'll do one more example. Rain has been subdued, but still, we better get going a little early today. Okay. We'll do. What about okay? Problem 35, part F. We'll do 33 part D. You first try them, then I'll do it for you. File to these two. Thirty-three part D and 35 part F. Right. First, I'll do problem 35 part F. It's not very difficult. I'll straight away start with the left-hand side. Oh, no, let me write what it is. What you have here. Cosec theta minus 2 cot 2 theta cos theta is equal to 2 sin theta. This is what you need to show. We can start with the left-hand side. Cosec theta minus 2 cot 2 theta cos theta. Now we have no clue. Anyway, the final answer is in terms of theta. So the line of thinking should be like this. You have to convert this into theta, this part. So I'll write this as 1 over sine theta. This is cos 2 theta over, if you want, you can write it as 1 over tan theta. That's also a possibility. Cos theta. Still, that's not it. Huh? You have to convert these two into trig functions in terms of theta. There's only one formula for this. That is 2 sine theta cos theta. Hmm? Now, there are three formulas for cos 2 theta. And you can see that a lot of these terms will cancel out. Cos theta will go away with this one will go away with that too. So what do you need? Finally, you need 2 sine theta, right? 2 sine theta. So you need to write everything in terms of sine theta. Now, there are three formulas. We'll see. The formula sine, the other end. So 1, 2, 3. Which formula would you use? 1, 2, or 3? 3, because you need the answer in terms of sine. So you have to replace cos 2 theta by 1 minus 2 sine squared theta. 1 minus 2 sine squared theta. Now sine theta is the common denominator. You have 1 minus, when you multiply this by minus 1, minus sign, you get minus 1, minus times this plus. These two will go away. But once you, okay, after you cancelling the, after cancelling these two, don't try to cancel sine theta at this point. Don't do that. It's wrong. Because you cannot straight away cancel sine theta before cancelling these two. So once you cancel these two, in the next step, you can cancel sine theta. Make sine theta cancel karo, sine theta the mooling cancel kari, make the mooling cancel kari kila danne. Because you cannot cancel sine theta with this setup before cancelling these two. Therefore, once you cancel 1 and minus 1, you have to go to the next step. Now you can divide both sides by sine theta, both upstairs and downstairs by sine theta. This will be 1, this will be 2 sine theta, which is the right hand side. 33D, that's what I can remember. 33D. It's also not very difficult. Sorry, plus 1 is in the upstairs. This is equal to sine squared 2a over 4 sine to the power 4a. You can clearly start from the left-hand side. Now you can, if you want, you can multiply everything by cos 2a. Or you can write it as 1 over cos 2a, 1 over cos 2a. I think best thing is to multiply it by cos 2a. Last time we didn't do that. We did something like sec 8a minus 1 over sec 4a minus 1. There you cannot do it because it's not the same function. Hmm. But in this case, both are secant sec 2a. So multiplying this by cosine 2a will make the trick. Huh? It's easy. You multiply both by cos 2a. So what you get is cos 2a times sec 2a, 1. They are reciprocal functions. This will give you cos 2a. Downstairs you get 1 minus cos 2a. Now you can replace this one by 2 cosine squared a and 2 sine squared a. Or you can replace this by, now you need the ratio. Therefore substitute, now you have 3 formulas for cosine 2a. Substitute uh, the formula that contains minus 1. Then this will be cancelled. This will go away. Substitute the formula that contains plus 1. For the cos 2a sitting in the downstairs. That's also a possibility. 2 cos squared a minus 1. 1 minus 2 sine squared a. So in the upstairs, since these two will go away, you get 2 cosine squared a. You can easily show that it is equal to 2 cot squared a. But that's not what you need to prove. You need to come up with this one. So look at this. You have sine squared a. You don't know what to do with the upstairs, but clearly now you need to multiply the downstairs by what? To get 4 sine to the power 4, you need to multiply this by again 2 sine squared. So we'll do that. You need to multiply this by 2 sine squared a. Then you get 4 sine to the power 4 a. Downstairs, you get 4 sine to the power 4a. Upstairs, what do you have? 2 times 2 is 4. You have 2 squared, sine squared, and cosine squared. How do you write this one? If you have x squared x squared times y squared times z squared, you can write it as x, y, z quantity squared. Right? So similarly, here you can write 2 sine a cos a quantity squared. Because you get 2 times 2, then you have sine squared, you get cosine squared. Now what is this? This is sine 2a. This is sine 2a quantity squared. So you can write it like this. Right? Okay. So, right. Next week, we won't have this weather next week. Therefore, we can have the class from 2 to 6. We can start section 3.5 next week. We can finish it off next week. Then we can start section 4, which is inverse trigonometric functions. Right? Once you are done with that, what I'm thinking is the following. We can do the rest of the trig parts like trigonometric equations, solving triangles and trigonometric graphs uh, online. Like we can have a class from 7 to 10 and we can start vectors soon after we cover uh, the inverse functions and we can have those lessons in our regular time. I think we should cover the syllabus at least by July 2026. So we can cover the syllabus in advance at least 3 months before the exam. This time I covered the syllabus by September, 1.5 months before the exam. I think with you guys, I think I can cover it 3 months before the exam. If we cover it well in advance, we can prepare better. Otherwise, towards the end, if we cover big sections like center of gravity, simple harmonic motions, with the workload you have at that time, because you have chemistry and physics, towards the end, nearly in last 6 months, 50% of physics, 50% of chemistry will be covered towards the end. So the load will be too much. කියන්නේ එතකම් පේපර් එකේ ගොඩක් ඒවා කව වෙන්නේ නැහැ. අන්තිම 6 months වල තමයි 50% ගාන යන්නේ. දැන් තාමත් ෆිසික්ස් වල ඔයගොල්ලන්ගේ මෙකැනික්ස් නේ. නෙක්ස්ට් වීක් වල සාමාන්‍ය ෆෙබ්‍රුවරි මාර්ච් වෙනකම් යන්නේ මෙකැනික්ස් තමයි. අන්තිම සෙක්ෂන්ස් ගොඩාක් තියෙනවා අන්තිමට. ඒ ටික අන්තිමට එකපාර කරන්න. ඒතර ඒ හින්දා ලෝඩ් එක වැඩි අන්තිම 6 months වල. ඒතර මැත්ස් වලත් ඒ ලෝඩ් එකම ඒ කියන්නේ you don't have enough time to prepare for that. ඒතර ඉන්නේ අග ටික හරියට ෂුවර් නැතුව තමයි පේපර් එකට යන්න වෙන්නේ. ඒක අපරාධයි. ඒව ලීසි. හරි ඒ නිසා මේ අපි පුළුවන් තරම් කලින් කවර් කරලා තිබෙද්දී ඔයගලන්ට පොඩි බ්‍රීතිං ස්පේස් එකක් තියෙන ඔක්කොම ඉවර කරන්න. කියන්නේ දැන් මං කරාට විතර බෑනේ ඔයගොල්ලෝ ප්‍රිපෙයාර් වෙන්න ඉපා ඒකට. කියන ඔයගොල්ලෝ ප්‍රොබ්ලම්ස් කරන්න ඕනේ. ඒකේ ඕනම විදිහ එකක් කරන්න පුළුවන් වෙන්න ඕනේ. So you need some breathing space there. So if you cover it by July, then you will be in a better shape when you go to the exam. So what I think is that after section 4, it should be covered in the class. Then we can cover the rest uh, like online. Like online means like 7 to 10. We don't have to spend much time after that. Probably 6 classes, 5 classes. After that, I don't want to do that because otherwise, this will go on like forever. Like you can at least you have to spend at least 2 more months on trick, right? Therefore, if you do it online, I mean the latter sections, then we can start vectors as soon as possible. So that is applied. We can start applying. Uh, so if you do that, I think without any difficulty, we can cover the syllabus by July 2026. Hmm, right. So I'll see you next week. Uh, we need to have a discussion of this paper. I think last time I gave you the paper, but we have to discuss it. Probably I'll let you know the date and time. I don't think, because I'll be little busy till next Monday. I'm busy with giving recommendations, right, for the students who are going abroad. So probably I don't think this week we'll have a time for the discussion, but after Monday we'll do that. Hmm? So I'll see you next Wednesday, but Wednesday for sure it will be a class from 2 to 6, but I'll give you a little break in between. Hmm? Right.